Hey, Algebra 2. Yesterday we were learning how to invert graphs. It seems like kind of a random thing. What is an inverse? Best way I heard it described was Ollie in sixth period. She said an inverse is something when it's flipped. Uh, in my brain, I go straight to thinking of something as opposite, but that's not quite inverse. Flipped is a way better way to think of it. So when we were talking about graphs yesterday, when you guys graphed on learning stations, the first thing you did was you swapped the x's and y's. You literally took the coordinate points. If I had the point, let's say 5 comma negative 3, you swapped the x and y's, and the original function, it was 5, negative 3. The inverse function, it was negative 3 comma 5. This doesn't change when it comes to algebra. So algebraically, let's get rid of that. Algebraically, we'll do the same thing. So here today, your whole focus is not going to be on graphing. We'll deal with that again tomorrow. I want to swap focus while I'm out of class, and we're going to instead focus solely on inverting functions. And you'll notice I put steps over here. Step 1 is the same as yesterday. We're just going to swap x and y. So if I look at this, I get y. Oops, let's do better. Okay, I have y equals 3x plus 7. For step 1, it's going to be the same thing as yesterday. I just swap x and y. Where it used to be y equals 3x plus 7, I now have x equals 3y plus 7. That right there, that is the inverse function of that original one. Those are inverse functions. If you graph both of them, you would see that the first one is reflected across that diagonal line like yesterday. We could be done, but of course we're not, because we can't graph this function the way that it is. All of our tools revolve around having y by itself. And so I have to solve. What I have to do now, and this is going to be the part that's most of the work, is I have to solve for y. When I look at the right side where y is, I'm looking at the equal sign, y is on the right side, there's a 3 and a 7. I have to get rid of those two things. And once I've gotten rid of those, now I'll have y by itself. Now I'll be finished. I'll have the inverse of the function, and it will be a usable inverse. So when I'm solving, I like to work from the outside in. I'll start by subtracting 7 from both sides. Once from the right side of the equal sign, once from the left side. Those 7s cancel. And on the right side, I now just have 3y. On the left side, what's interesting is for pretty much all of your solving today, you're not doing anything. X minus 7, some of you might say, okay, that's negative 7x. Or maybe you'll say, oh, but that's 1x, so that's negative 6x. No, it's none of those things. That's a letter, a variable. That's a number. They don't combine. They're not like terms. And so when I ask you, what's x minus 7? Your response should be, yeah. Yep. What is x minus 7? It's x minus 7. Can't do anything with it. Let's go one step further. I want to get rid of the 3. I'll divide by 3. Well, what is x minus 7 divided by 3? Yep. It's x minus 7 divided by 3. And I'm done. I want to write this in a slightly different way. I know I didn't have function notation here. Most of the time, instead of y, we'll have f of x. And so our final answer should also be in function notation. It'll be f minus 1 of x equals x minus 7 over 3. That is the inverse of the original function, x minus 7 over 3. If you graphed that, it would look like the inverse of that. Okay. Now, the next step is to use a composition of functions to verify your two functions are inverses. Whatever that means, that's going to take me a bit. And so I'm going to do that in a second video. You guys get to see 2 videos of me today. Yes. Instead, I would like to show you a more complicated example of inverting. Okay. It looks more complicated. It's one more step. It's really not more complicated. So here I have the function f of x equals x plus 2 quantity squared minus 5. Well, I right away have a problem. I'm supposed to swap x and y, but there's no y here. Well, there is. That right there is the same thing as y. And I've had students in the past kind of stumble over that. And so what I'll do is I'll just rewrite this function, and I'll replace the f of x with y. Those are totally interchangeable. You don't have to do that first step. You can go straight to swapping. I don't want to write f of x the whole time, and so I'm going to stick with using the character y for my output. And so now I'll swap these two. my function f of x equals x plus 2 squared minus 5, or in other words, y equals x plus 2 squared minus 5, becomes x equals y plus 2 squared minus 5. That is the inverse function. Okay, I almost could be done because that's what it is. But in order to make this useful, I will solve for y. And so that's going to take me 3 steps. When I look at this, I have to get rid of the 2 and the squared and the 5, the minus 5. Then I'll have y by itself. I'll work from the outside in. That ends up being the least complicated route. So I'll start by adding 5 to both sides. What's x plus 5? Yeah, it's x plus 5. That's going to happen pretty much every time here. Okay, now this appears to me to be pretty obvious. Minus 5 and plus 5, those are inverse operations. Everything yesterday and today is all about inverses. Those are inverse operations. Okay, what's less obvious is what's the inverse operation of squared? The way we say it out loud sounds right, but the symbol seems kind of weird. So the inverse, of squared is square root. If you square, that's a nice square root symbol. If you square something and square root it, those are complete opposites. And so in order to keep the equation balanced, I have to square root both sides. Square root and squared, they cancel each other out. On the left side, what is the square root of x plus 5? Yep, it's the square root of x plus 5. On the right side, the squared is now gone, and I have y plus 2. Look at what I've done. I got rid of the negative 5 by adding 5. I got rid of the squared by square rooting. And the left side is just sort of all these things are getting tacked on. Now it's x plus 5. Now it's the square root of x plus 5. Last thing I'm going to do is I will subtract 2 from both sides. And you may be tempted to write square root of x plus 3. And I would understand that, right? That's 5 minus 2 is 3. But a couple of problems. Number one, that 5 is inside a square root. That 3 is not. So they don't connect. The other thing is, whenever we're finding inverses, really the stuff on your left side, it's just keeping a record of all the things you've done. What have you done in this process? You added 5 to both sides. You square rooted both sides. Then you subtracted 2. You should see all those pieces. I like to make sure that it's very clear that this plus 5 is inside the square root and this minus 2 is outside. So I like to use parentheses here, and that makes it clear. And there are my 3 steps to solve. Add 5, square root, minus 2. My final answer, I'm going to go back to function notation. I'll just put f negative 1 of x equals that. So square root of x plus 5 minus 2. I promise you, if you graphed that, it would be the inverse of the one that we had above. That is how you find the inverse of a function. You swap x and y, and then we take it further and we solve for y using inverse operations. Add, subtract, square root, cube root. Please take your time looking at my solutions as you're working. You're now going to see a second video where we use a composition of functions to verify those 2 functions are inverses. I just want to say this. I'm going to say it now. I'm going to say it in the next video. You're getting a worksheet today. The first 2 pages are all graphs. We're close, but I don't think we're ready for those yet. And it'd be tough to teach those by video. So instead, I want you to skip to the 3rd and 4th page. Skip to problem number 5, 5 through 8. Those are all inverses of functions. They look really similar to the ones that I just did in the video. Use my posters, use solutions, but skip to number 5. Okay, good luck.